That's looking good. Let's see if we're live. We're live. Welcome. My name is Blades, and yep, this is Amberskies 2019 C++ game programming. It might change into more of a club style depending on how many followers we get and how much interaction we get. You can contact me by email, daocamberskies@googlemail.com. I have a website with a contact button on it, www.amberskies.org.uk. Something just flashed at me on a different screen, which completely broke me. Got my attention. I'm here on Twitch at Fraser Blade Sharp, obviously, because you're probably here looking at this. And I'm on YouTube at Amberskies. So, that all said, this is brought to you by Amberskies. If you like what you see, consider supporting us by a donation or even long-term support with Patreon. The buttons are there on the Twitch page. Like, subscribe, follow, whatever options you're given. Do them all, and we'll build a good community. We'll build Amberskies, we'll get all the electronics. I've just spent more money this weekend getting some more electronics. Yikes. And what is on screen right now? What is on screen is where we left off last week. Yeah. I asked for a square. What did I get? I got exactly what I asked for. I asked for an XY coordinate, and yeah. Good, eh? Have a look at the coordinates and you'll see. It should be a square, that. It should be half and half. Yeah, it should be a square, you're quite right. But it's because of the size of the window. The window is 500 by 900, which is nearly double. So it's nearly double the size. So if you look down the centre of it, there's your square. And I did that on purpose. I made the window 900 by 500 on purpose to show you that there's a problem, and it's called perspective. And that problem is the first thing that I wish to deal with today. It's with the display, so let's go and have a look at the display. That was me just getting up to date on my bits and pieces. So, game.cpp. No, we're looking at window.h, and we have things here which we now have to change. So, no, that's looking good. Getting bools where we should do. We're getting voids where we should do. I'm happy with what I'm seeing. That's great. Now, what you will hardly ever see anybody do is what I'm about to do next. Yeah. Okay, so what do I need to do it? Is the question. We need GLM, the OpenGL Maths library, and this time I keep saying we're going to need it, and then I keep taking it out. I did it with Renderer, I took it out. I did it with Entity, and I took it out. But now I definitely need it because I need perspective, and that needs maths. So I am not this time going to go through the maths. If you want me to, ask me to. I don't mind. Oh, let's put a message in chat. Hi all. There we go. Let's bring the chat up properly so I can see it in case anybody wants to ask questions, give ideas, or just generally chat with me. If you just want to chat with me, that's fine. Patrons do get access to Discord, of course, so I've linked that with my Patreon account already. Let's see, what should we do here then? Window 3DH. This one, this little baby. I'm going to separate the includes. No, I'm not, because they are still in a library. So, hash include. There's a couple of things I want. There is going to be a matrix 4. Will I need vectors? I will. Yes, I think I will. We'll include them anyway, because we can. So, it's GLM. If you put in GLM and then what it is down here, glm.hpp, that's a big file. That's a very big file, and I don't want all of that. I only want little bits of it. So we're going to take ext, I think. Yeah, we'll take ext. And I will take, for the first one, vector float 3. So basically what I'm doing is choosing which ones I want. I'll have... we can have precision or normal. I only need normal for this, really. I suppose... Will precision help it? Yes, indeed it might. That's interesting, but then I'd have to use precision throughout, and that's more expensive on timings. No, I'll go with the standard, and we'll take a look with that, shall we? That gives us vector 3s, x, y, z's. You know, I'm thinking about it, and I'm thinking, well, we used vector 4s, didn't we? Should we be using vector 3s? I think for this part, yeah. I think we're going to be alright, because we're not going to end up with any of these vectors. We're going to be ending up with a matrix. And on that note, we better include it. So, GLM ext, and we'll have matrix. Which one do I want? Float 4. Four by 4. I think that's going to be the best one to take to match with that vec3. Yeah, that'll do. Okay, I'm happy with that. So that will give us let's see, vector, that's type, isn't it? Type. Oh god, I'm doing well with this type. Vector 3. I.e. x, comma, y, comma, z. And this will give us type matrix for x4, i.e. a 4D matrix x, comma, y, comma, z, comma, w in OpenGL format. which is important that we know it's in OpenGL format, because if it's my maths library, it isn't. I use row major, and OpenGL is column major. So I'll just put that in, column major, because that's OpenGL. So if people know what that is, that's fine. If you don't know what it is, doesn't matter. It's a little black box of magic jiggly numbers, and we don't really want to know how it works for this. We just know it works. Because I know the maths behind it, and I know what's in that little black box, so don't worry, it works. Let's see, what else can we include? We can include what we want today. And that will be perspective. And that will be glm/ext/ which one is it? It's matrix clip space, I think. I think that's correct. What choices do we have? We have projection. Map object coordinates into window coordinates and reverse. I think it might be matrix projection, you know. Let's have a look. Let's see what it gives us. We'll find out as we go, I suppose. Projection. Yeah, we'll have you. And what does this give us? Functions to map object coords into window coords. That's what that one does. I think that's what we're after. So what that means is we can take a 3D object and map it onto a window. Is this the same as clip space? 1 second. I think it is, you know. Because the clip space will transform a scene into the clip space. Yeah, I think I'm going to go for that. Functions to transform scenes into clip space. Clip space is a small little space which is held and used by the depth buffer. Yeah, because we are using a depth buffer, so we do want to go to clip space. Yeah, I'll do that then. So we'll take matrix clip space, and we'll try that one out, shall we? So matrix underscore clip underscore space. There we go, we'll take that one instead, and hopefully we will get it right. Now the whole object of doing this is to give ourselves a chance. I'm just checking something now. A chance at getting our perspective sorted out so that things don't look stupid. Alright, so it's not here. Oh, it does have a stream health though. Why don't I have a stream health? Because I haven't asked for one. Okay. I have. So Where is it? It's not there. Is it underneath here? No. Huh. I've asked for something and it hasn't given it me. Okay, alright, I've got it there. That's fine then. Right, we're at 0% dropped. It's just I had a couple of dropped streaming thingies last week and it really wasn't good. So, what do we need to do here? We've added 3 includes instead of 1. So we cut down on the code that is brought in so we don't bloat our game display. Window 3D. What can we do now then with that? Let's have a look. With Window 3D, we need to calculate the projection itself. Do we have a width? We have int width and int height. Okay. Well, it's going to be a void, isn't it? So we can put it down here. Public. Is it? No, it's not going to be pub. Is it? Is it not? No, I don't think it is. I don't need it public, do I? It's a calculation. Void. It's window 3D perspective. That's a bit of a long name. Set per. Is it perspective or projection? Perspective. Now that needs to take in width and height, as you may guess. Int width, comma, int height. Are they consts? I think we can call them consts. We're not going to be changing them. Oh no, we can't. Okay. Alright, so what we first of all are going to need is a function, aren't we? So that's okay. Calculates the current perspective for the window. There we go, that'll do. We get a little thingy. Create definition. Woo! Thank you. There we go. And in here, I'm going to put m_width equals width, and m_height equals height. That's okay. We're alright with that so far. That's pretty obvious stuff. Then we're going to need a variable. We'll call it perspective. And I'm going to do something strange. I'm going to put it here in public. GLM : it's going to be a matrix. So that's mat 4. Yep, that's okay. And we're going to call it m_perspective. And that is storage for a 4D matrix perspective. Perspective for the window. Storage. Yeah. 4D matrix perspective. Okay. We'll pop that in public. Now, you don't often see people do this because that's private. Nobody can access these. But I'm doing this on purpose to make a member variable public, so other programs or other functions can then access it. Anybody who's got access to the Window 3D class has access to the perspective. And that's very important later on, because we do need that inside our renderer here. Or we will need that inside our renderer here, should I say. So yeah, we'll save that. Let's go and program it. Should be down here somewhere at the bottom. So m_perspective. Now what does it equal? Oh, this is lovely. This is lovely. So it's going to equal GLM : perspective. And what do we need? 440 GLM packed IP perspective, TF of VY, aspect near and far. So it just needs field of view, aspect ratio, near plane and far plane. I think we can do those. I'm saying we can do that, but I haven't set it up, have I? Really? Let's go back to our window a minute. You see, I've got all the hashing clues, but I've not really defined anything, have I? I haven't made any definitions. And I want it to come under display. So here. And I want a hash define. Oh. I'm not really happy that it goes there, but hey ho. I'm going to set perspective here. And it's going to be field of view. And we're going to put in radians. Now field of view is up down and not left to right. So about 45 degrees will be 2.5-ish. 2.24, 2.26, 2.26, 2.26. We'll have you. May as well put these here if we're going to do that. It's going to be perspective, yeah, perspective. What else can we have? We can have the near plane. Now I'm going to do this in meters. So for now I'm going to make it 10 centimeters. So that's 0.10. That'll be alright. There we go. That's that done. Hash define. Perspective. Why do I do it this way? It's so that if I want to alter any of this, I can just go to the header file and alter it. Yeah, it's as simple as that. rather than search through all the code and find out where it was used. It's to make life easier for the next person that comes along. Far plane, isn't it, we need now? Far plane, we'll put 2. I'm going to make it 50. I usually make it 100, but this time it's going to be 50. 50 meters. I want a 30 by 30, and I've got to go away, so I might clip. And I don't know if I will or not. That's why it's called a clip plane, because you might clip it off. Don't think I will. Head calculations aren't working today, that's interesting. Neither is my typing. Okay, just bring those in line and save before he decides otherwise. So that allows me to go to my header file, alter the perspective without having to go into my CPP file and try and find it all down here. So as we know, I do that and I do a semicolon. So what's our first thing? It was FOV. So it becomes perspective, and it was field of view in radians, so that's that one, comma. Aspect ratio is width over height, height over width. Which way around is it? It is width divided by height. One second. Yeah. I'm sure it is. I'm sure it is. Don't worry about it. I'm sure it is. So, we're going to have a static cast. This is something you don't normally see me do, a static cast, because I usually have all of my variables in the correct type. But this time, it's width and height in int, because they're in pixels, and you can't split a pixel in half, so they're all ints. Yeah, it should really be unsigned ints, I suppose, but hey ho. So we're going to have to use a static cast because I want to divide them and to get a float. So static underscore cast to float, and it's going to be m underscore width and we're just going to divide that by m underscore height, like that. And we can put a bit of space in here so we can see things better. So that'll give us an aspect ratio. Near is perspective near plane, and that will be perspective far plane. There we go, that's it. So that's the list. And how do we notate all of this? Here we go. Function given by you. Actually, I'll take the lot. There we go. So that's okay. Next line. I mean, I've made it more obvious than it really should have been, but that's your field of view. So I'll put that in full because I've used an abbreviation there. Field of view. Oops, if I can spell properly today, which I obviously can't. Do I have coffee left? In the vertical. Not the horizontal, the vertical. That's important, so that's up and down. It's because of the stretching on the screen. I'm going to try and keep it towards about 45 degrees, which is around 2.5 to in between 2.5 and 3 radians. It's one of those weird numbers. Let's see, 90 degrees. No, 180 degrees. 1 pi is... Ooh, I think I've overdone this. 2 pi r is 360. 1 pi r is 180. So it's half a pi is 90. Half pi is about 1.5, so it's 0.75, isn't it? I think I've really overdone it. Okay, we'll go down to 1 and see how it looks. Because I want 45 degrees-ish, or over. So that's about 1/3 of 180, which is 60, isn't it? So that's about 60 degrees, that. Interesting. Okay, I'll leave it at that then and see what happens. I think it's too much. We'll test it and find out. So this gives the aspect ratio. And now we're all in caps. The aspect... come on, fingers. I'm getting a bit annoyed now. The aspect ratio... I get annoyed with my fingers when they don't work. Ratio for the viewport. In other words, whatever you're viewing from or through, window or TV or whatever. There we go. The closest any item will be drawn. So clips to your nose. And this one will be the furthest. Any item will be drawn. Sorry about the speed. I'm using one hand because my left hand's died a bit for a minute. Yep. So that's X for given values to member variable. In other words, we can store it and use it elsewhere if we want to. We really should set them in a different function, and this function should only really contain that. But I don't see the point, because I don't think we're going to be using them anywhere else. I think that's the only time when we're actually going to use them, so we'll set them and use them at the same time. It saves an extra function call. It's looking good. That's looking very good. Okay. Sets the current perspective for our window. View port. Copy that. Lovely, looking good. I will replace you. Okay, we'll get rid of you. That's cleaned up. That's okay. Now, because we have M perspective public, we can actually do the calculation in private. M perspective will then change whenever, and it doesn't matter. We can change it anytime we want, and it will then automatically get picked up by any function that's using it. Very clever system, but it works nicely. You'll see a lot of people doing getters and setters, so they would do get M perspective as a function. Don't need to. Set it as a function. Don't need to. I can get it and set it outside. It means I can now take this calculation and it's portable. I can place that anywhere in these programs that I want. In these functions. It doesn't have to be here, but it's convenient for it to be here because of the width and the height. You see, where are we going to get them from? And the only place we can get them from, really, is one, when we start. So, initialize. One, when we initialize. And secondly, from the operating system, if we do, you know, bottom corner moving or side moving or something like that, if we resize the window itself, which we can do. So if we look now at our initialize window 3D, we create the window, M width, M height, title, and everything like that, but we don't set its perspective. So check that the window has initialized and initialization if false. So it comes after that. Context is a that surrounds the event and provides resources. Yeah, I remember that one. That was a good one. That. So here, all we want to do is set perspective, width, height. There we go, that's it, done. So let's just split that down. There we go. Lovely. This is looking good actually, nice and easy. La 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 la. Ding, ding, ding. And that's width, isn't it? There we go. Paste those in. Nice and easy. You see, it doesn't have to be flashy or anything. It just has to work. Now, does it work is the question, because we now have a perspective. Now, we're using it here and we're setting it, but are we actually using it within our windowing, within the drawing renderer? Well, the answer is no, because it would show up in here. So the vertex shader, it would show up in here. So let's put it in, and I'm going to put it in as a different type of variable because it doesn't change. Doesn't matter what positions, normals or colours you go through here. When we're drawing our object, the perspective doesn't change. Well, not for that draw call anyway. It might do for the next one. But for the full draw call, it's not going to change. So it's a uniform value. It stays the same, uniform value. So we're going to have a one here, I think. So we'll have an in. We'll make it uniform. And we will make it a mat 4. And because it's a uniform, I always start with U underscore and whatever it is. And in this case, it's perspective. Some people might call it projection. Perspective, projection, same thing. Dunno. Semicolon. And what we're going to do is hopefully get it right. Is it just uniform in? Yes, it is, isn't it? Okay, I can't remember now. I always thought it was in uniform. Oh well, you know what's going on then, don't you? I can't remember. Which way round does it come on? Which way round does it go? Yeah, let's have a look. Shaders. I've got notes on shaders, thank God. Let's have a look what I'm trying to do. It's uniform. Oh, there's no in. Okay. Fair enough. There you go. So all we're going to do now is take our... It should really be projection, shouldn't it? No, I've called it perspective now. All we're going to do is take our perspective, copy it, and paste it into there. So we're going to take a vec4 position and multiply it by our black box of jingly jangly magic numbers, which give us our field of view, near plane, far plane, and all the rest of those lovely little bits in a matrix. And that should then take what was being stretched and put it back into a square. Why do I doubt all of this? Oh God, why do I doubt myself so much? Is it because maybe that ain't the way it works around here? Or it's because I'm Blades and I'm not sure if that's going to work or not. One, I've never used GLM before, so I'm doubting that I'm using the correct function. That's basically what it is. But that's how it should work. So that's our colour. Fragment doesn't alter, so we'll go with colour. We'll pop you there. Alright, so I've updated there, but our renderer still isn't using it. So in our renderer, which we haven't really been too happy with, we've only just put little bits of notes in so far, that our lovely vertex array object is telling us which data to set, but it won't set the uniform. It's in the program. The program has a listing. So it's something to do with GL get uniform location. A bit like that one there, but without the subroutine in it. That one. Right, okay. It's going to need the program and the name. GL char star name, that's fine. So the program is shader dot program ID, and it's going to be uniform underscore perspective, and that's it. Lovely. Make sure 100% that that matches that, and the best way to do it is to copy it and just paste it, just to make sure. Don't want any errors there. That will get the uniform location. It should give us a return. It doesn't tell us. What? Okay. Thank you. So the uniform location is now U1 for a minute or two, whilst I get this together. And after we have bound the VAO, which sets up all our attributes, actually it doesn't really matter, does it? Nope, doesn't really matter. What we got coming in, a shader, a VAO, and an index count. Darn it. Darn it, darn it, darn it, because now we need the window. Yeah, that's okay. Who's calling you, Mr. Renderer? Game, are you doing this to me? Window update. Okay, render scene, here we go. So we are using a render scene, yeah. Yes, I found you. Game OpenGL render scene. Game OpenGL render scene. So it's this bit here. What we will need is a matrix. So I was right. We'll nick that. We can steal it from window3d.h, can't we? And it's line 21. So in renderer.h, we're going to have to include that. Otherwise, we can't have a matrix. So we've got the shade data, the gluint, GL size I, index count. This is going to get too long. Okay. Comma, GLM, colon, map4. And what we're going to call it? PER perspective. Yeah, we can do that. We can do that. We're heroes. We're heroes. Might as well make it intelligible. Copy you out to yikes here. So we now have to provide the perspective. So back in game here, all we do is add to the end of that, comma, where are we? So where's window? Window is just window. That's nice. Window dot and perspective. There it is. There we go. And that's that done. Fantastic. Yeah. Because I made it public, we can just do it that way. You can just add it to the function. So we now have it. I can get rid of you. I can get rid of you. And we want to look at you. So we've now got map 4 perspectives. That means we can now set it. And how do we set uniforms? I'm trying to do this from memory, by the way, because I've decided I want to try and do as much by memory as I can without looking it up in my notes. So it's going to be... Is it just going to be set? Uniform? No. It needs to be a matrix. Is it not a 4x4 thingy? That's 3D. 4 floats, no. No. Ah, GL uniform matrix 4D, please. Yay, 4x4. 4x3. $4DV. What's a 4DV? Is it 4-dimensional value? I think it is. D is integer, isn't it? But they use I. I don't believe this. I'm arguing with myself over a 4-dimensional object. Oh dearie me. Let's see what I can do about that, shall we? Nothing there really, nothing there, nothing there. Okay, I've got nothing in that lot. I don't believe this. It's in... I actually have this locked away. Right, it's gonna be matrix X for FV. The next one down. Yeah, I was right to query it. So it's that one. We'll open that one up and it'll give us all the stuff for this one, won't it? So GLI int location, we just got it up from here, so it's U1. We know the location. What's it need next? Size I count. Just a 1, please. Just a 1 variable. Weird. Boolean transpose, false. Because, GLM works in the same way as OpenGL, so it doesn't need to transpose. And the value is... Ooh, orange juice would be nice. No, it's alright. You're taking that down, aren't you? Oh, never mind. Thank you, love. Can you close the door at least? Right, this is the hard part with matrices, because we're going to have to give it a star value. So it wants the address of our matrix perspective, and that would be the first location of it. What's that one there? Operator. I think I can use an operator. Oh, right. No, you can use the operators on this one, isn't it? It's GLM. So it's 0 in there. 0 again. That's it. That's how GLM works. It works it completely differently to the way I do it. So there we go. How can I help? No, it's empty, love.
It's not empty.
Trust me, it is.
You just need to have a sneaky look at it. It's taken over the whole bed when you get up.
She's a darling. She's looking after me, and she's just telling me that one of the cats has just taken over my bed. Totally taken over my bed. So that's how it looks in GLM format. That's what I'm going to call it, because it is to me. What that actually means is the address of the 0th column by the 0th row. In other words, the first item in the matrix. That's its YX, I suppose, XY. I don't know how you want to work that one out. So that's how we send a uniform through. Normally, we use something better than U1. Like, how about I don't care. I don't care, because this is going to change totally. So we've now sent that value in to our shader. So what's going to happen? Dunno. Don't know if I got any of the calculations right today. I don't know. Hold your breath. Why is this just stopping on that, not giving me the details? So we obviously got something wrong. And I can tell you exactly what it is that we got wrong. We don't have a model matrix. Yeah. So there you go. Isn't that typical? So everything's correct, by the way. That's what it should have done. It ran. Still, what is it with this output not giving me stuff? Gives me a load of garbage afterwards. All of this should have come up. Never mind. Error list. No warnings. Good. That's what I want you to see. So that's what happens when you just put perspective in. Nothing that we have drawn is now on the screen. Oh. Let's see if I can just tweak it so that it is. Entity. No, I've already tweaked it. I've already put the ones in. Darn it, I thought I might not have put the ones in. And I have. Never mind then. Never mind. I thought I might have set those at 0. So we need another uniform. And this can now change to, actually it's U3. I'll change that to U3 because there's 3 of them. What we need now is another uniform. We need something called a model matrix. what the model matrix does is puts our model into the world. And we haven't done that. We've just gone, oh, okay, entity, yeah, So let's just say that a second. Who creates our entity? I bet it's game again, isn't it? Game, you're doing too much. Yeah, there you go, terrain. So we're passing terrain in direct. Shader, terrain, VAO, terrain. No, we're not. We may as well just pass terrain in. And get it over with. Because we're now going to need model matrix. So we need a... You see, I've got gets here. Get model matrix. Oh, that's awful. Okay, I'll leave it as it is because it's bad. So here we go, back to this entity. This entity is going to get deleted, don't worry. It really is going to get deleted. Now, if you remember rightly, I said we're probably going to need some GLM here, and then I wiped it all out because we didn't do it. Well, now we're going to do it. So, what we're going to need? We are going to need... What have we got? Oh, right, we haven't even placed it in the world, have we? That's why it's not on the screen. It's because it's nowhere at the moment. It's not even in space. Okay. So we'll do a hash include. I'm just thinking the vec3 and the mat4 we can just take from the window. So those two can come in from window. We'll have them too. And then we're going to include something different, which is GLM. Which one do I want? EXT. And I'll have a matrix transform HPP. Yeah, it's HPP for C++ instead of just H for C. They've done it that way because they think it might help. There you go. Gives translate. What else does it give? Rotate, scale, and identity. There we go. So that's what this gives. So translate means position, so we can position something in the world. Rotate means we can rotate it. Scale means we can scale it, grow it, shrink it, enlarge it. Identity means we can set a matrix to 1, or the matrix equivalent of 1, so that if we multiply it or divide it or do anything with it like that, then it won't affect a calculation. But now we need to calculate our model matrix. Or model to view, some people call it. No, I'll call it model matrix. I'm going to try and keep it simpler. I could just make those public. To be honest with you. Because this isn't really going to do much. We create the entity, yeah, great stuff. Okay. So after creating an entity, you would probably have void know how to put this. How should we call it? Don't like set. Calc. And that's what we're doing. That will take in GLM colon vec3 position. God, what else will it take in? Well, well, this doesn't read right. Oh, who wrote this manual? Can I go and shoot them? Oh, right. Okay, I know what they've done. They've been idiots. Okay. So that's position. It's called translation. So they've put translate in there, and I'm not going to do that because it doesn't mean the right thing to me. Rotation. How are they going to do rotation? Okay. Yeah. I can handle that. So it's 3 separate values. I can take it as... What is rotation in? Is it in degrees or... Thanks. It doesn't say. But it's in radians, isn't it? 1 second. Let's go back to the top and have a look here. It's going to be a GLM vec3 again. I'm going to use a GLM vec3. Stuff out. GLM colon vec3. I'm just going to call it rotation. And then it's just going to be a float for scale. Let's not try to overcomplicate things. What's wrong with this? That's correct, it isn't. Thank you. There we go. Rotation is handled slightly differently. And we are also going to have to make this available. So we are going to have a GLM, and I'm going to call it map4, and it's just going to be m underscore model matrix. I can't remember what we called the last one. No, we didn't even put it on. Right, okay. We'll call it model matrix anyway. For now. Okay. I'm getting somewhere now. I hope. Yeah, we're getting somewhere. That's fine. Create the definition. Yay. That's fine. How do we calculate it? Good question. Oh god, there's a lot of rubbish here. Okay, we calculate it as... Do we need perspective in here? We could do, I suppose. Not really. Okay, thinking time. I'm going to... how long have we been going? Yeah, we've been live over an hour, so I need some thoughts time. If there's any feedback, put it on the screen. I've got a little thing here that helps me think, which is called a cup of coffee. It's time for coffee because I've got to get this right, and I'm going to do it without referring to notes too much. So, yeah, you're going to suffer blades thinking. You're going to hear the cranking and gears in my head, screeching and whining. No, don't go over the edge. Back in 7 mins. Go get yourself a coffee. You're going to need it. Excellent. Sorted it all out within me head. You see, that works. All you need is a cup of coffee. Cup of coffee and the world's your oyster. Yeah. Pop you back there. Get rid of you. Right, okay. So, matrix multiplication happens backwards, so we have to do this the other way round. Okay, so it's locate first. How shall we do that? Oh, what have we got here? That's no good to me. What does their manual say about this? Anything? Oh yeah, here we go. So let's make a GLM. We'll translate, rotate, and then we'll scale. Okay. And I've put scale in as a float. Will that be okay? Yeah, I'm not sure. I don't like that bit. Map 4. So we are going to call this model matrix by the looks of it. So oh, you can't do that. No. Let's call this translate then. So, matrix for translation equals, it's going to be GLM : translate, open brackets. What do we have to do? We need a matrix to act upon and a vect3 to action it. Okay. So okay, GLM need a matrix mat 4 open brackets, and we'll just make it an identity matrix, which if I'm not mistaken is a 1.0f, and then I want position, so comma position. That should do it. Right, that's our translation. Right, I'm happy with that. It's this rotation business I don't like. What are they on? This is awful. The rotation looks awful. So the next thing that we are going to do is translate equals and it's going to be GLM rotate. Oops, rotate, yeah. How's this done? So the thing we want to act upon is translate, comma. What's the next thing? Angle. The angle, so we'll take rotation X. Can I have an X? I can. That's good. So T angle rotation X. It doesn't say whether it's in radians or not. Darn it. What is it next? It wants GLM Vec3. GLM colon Vec3 open brackets, and it's 1.0 f comma 0.0 f comma 0.0 f. Space that out, and that should be it. Yep. Semicolon. Oh, takes the spaces out anyway. Thanks. That's how you do rotation X, is it? Looks like it. The last Vec3 is just which way is up. So we said X is up. Or sorry, that's the it's the X axis we want to rotate around, not up. I think that's correct. I'm going to try it out anyway, and we'll find out whether it's correct or not, won't we, together? Okay, 1, 2, do again, 1, 2, do again. I'm going to do that for the Y. Turn that to a 0. Put the Y axis as 1. And for Z, I'm going to put that to a Z, and that to a 0, and put the Z axis as a 1. Okay. So that'll give me an X, Y, and Z. Then all we need to do is scale it. It doesn't tell us how to scale. That's not good, is it? Scaling, there's something about scaling that I remember in the back of my mind. Ain't that nice? Toolbox stuff. Don't we just have a scale? Let's look how scaling is actually done rather than GLM. Okay. It would need a scaling function to do that. So let's find one. So it'd be translate equals GLM : scale. There you go, it's got one. It wants the matrix, and then it wants a Vec3. Okay, so it wants the matrix, which is translate. And then it wants a Vec3. Oops. So I'm going to put GLM : Vec3, and it's going to be scale. Scale, comma, scale, comma, scale. I'm not having various scalings going on, so that should be alright. Should scale it equally. Whoops, don't do that. Do that. Right. That's correct. It scales it equally, so if you put the scale as you want it to like half the size, or put 0.5 in there for half the size, it will do it in the X, Y and Z equally for scaling. Now, because matrix multiplication is backwards, all of these operations will happen the other way around. I know, it's stupid. So what will happen first, it will get scaled, then rotated, and then translated, which is exactly what we want. We don't want it to go out into the world and then rotated, because then it would rotate about the origin of the world, or 0, 0, 0. We want to be able to rotate it and then put it out into the world afterwards. Scaling, you may as well do it first anyway. So that happens first, your rotations happen second, and then it is translated. You have to read it upwards. Yeah. That's that done. We now have our model matrix. So what I'm going to do is I'm going to call that model matrix, aren't I? Yeah. I'm going to copy that. I'm going to come here, and we are going to state that u equal translate. There we go. Now, when we create our lovely, lovely, lovely model, we have to make sure here that it actually equals something. So I've got an extra one now, which is m underscore model matrix, open brackets, and it's glm colon colon mat for open brackets 1.0. There we go, and that's what it equals. Perfect. Is that looking good? That is looking good. So now we have a matrix that we can get hold of. So, going back to our game, we have our printfs, okay. We have our terrain, piece of terrain, and we now want to terrain, and it's in this case a dot. And it's going to take a glm vec3 position. No, I've got it anyway. It's a glm colon vec3 open brackets. What position shall we put it at? Nowhere. 0, 0 point. So that's 0, 0 f comma 0, 0 f. I don't want to do anything with it. Comma rotation glm. Again, vec3. We will test this out after. I've got something on screen. F comma F comma F. It's that one, and the last one is 1.0f. That'll do. Alright, so how does that break down? That breaks down to that, comma that, comma that, comma that. I'm not breaking the vec3s down. Why not? Because it's easier not to. So this is, I'm just going to put position, and this is rotation. Right, okay, let's see if this works. So we now have that there. So after under perspective, we can now put terrain dot m underscore, oh god, terrain dot, oh, it's not going to let us, is it? That comma's not going to let us for a minute, so okay. Entity's done. Renderer. Comma. Actually, no. Perspective should be last. So it should be GLM : map 4. And we're going to call this one model. Magic. There we go. Lots of messing around with these. So that is now that. Yeah, it's getting big. I'm doing it on purpose this way, I think, just to show you the extent of its silliness. No, that's on render.h. Entity I've done. Entity I've done. Game doesn't matter yet. Render.cpp. No, can you just put it up for us? Thanks. So that's just got a bit bigger. There we go. That's good. And we now have a model which we can put in here as terrain dot model matrix. Thank you. Yep, that works. So we're now passing in a model matrix. We need now to be able to do exactly the same as what we did here. So I'll go copy. And this is U1. And this is going to be a model matrix. And here, just copy it again. And it's now U1. And it's model. That's that done. False. Ding, ding, ding. Yep, that's fine, that's fine, that's fine, that's fine. It won't find it because we haven't put it in our shader. And we can put it in our shader here at uniform mat 4 u underscore model matrix. Our model matrix goes there. It comes in to here. Copy. And it goes there. And that's multiplication, please. So our model matrix goes there. So we've got our perspective matrix and our model matrix. I don't usually put two in at once. Or maybe we should just do the model matrix first. But hey-ho. We should have probably done it that way around. Okay. Render. Oh god, I didn't check. Colorvert. Always, always, always do the copy on that one. Yeah, I got it right. Good. So U1 and U3. You're thinking, what about U2? Well, it's a nice band, and I really do like the music. But U2 is actually going to be a view. And we haven't got that because we haven't done a camera. So that's our camera, is going to be U2. Slurpy, slurpy. No idea if this is going to run or not. It might do. Yay, it ran, did it? Yeah. Wow. It ran. Totally wrong light, but it ran. Fantastic. Yay. So I must have got something right, and obviously quite a lot wrong by the looks of it. So that's how it's done. You add uniforms and matrices. So now I have to switch off the second one. So that's U. Okay, so I've just got model matrix and position. Run it with that. Okay, that's with model matrix and position. As you can see, the perspective isn't there. But as soon as I add perspective, it's going to disappear on me. And I put it all to zeros on purpose. Which means we can't see it, because we don't render at 0, we render at 10 centimeters away from our face. Oh, Blades, what have you done? I put it at 0, didn't I? So in the Z direction, we'll put it a meter away. No, we'll put it a meter away in front of us. And try that. There we go. But it hasn't done it. What's going on? Our perspective isn't working. Did I get it wrong, or did I get it right? I don't know. Let's have a look. Have I been doing my perspective the wrong way around again? So there's something wrong with the way I've done perspective. I might have used the wrong calculation altogether. Right. Open GLMVP with GLM. Let's have a look. Alrighty. Oh, it's this thing again, is it? Okay. With GLM. We've done the translation. I'm alright with that. Rotation. Angle in degrees. Okay. Rotation in degrees. Thank you. Alright. So I've got that bit sorted out. And it goes through a load of rubbish. Thanks. I fall over sleeping. Width over height. Put it in here. at the bottom. Width over height. So it's radians. Near plane, far plane. I got those right. Got all of this right, but I think something here is messing us up. And it's possibly the field of view. Okay. Build. Rebuild game. Ah, didn't put it in, did I? It doesn't matter, it's in the shaders. Oh well, it's happy building anyway. Shaders are loaded by the program, not compiled with it. No, that's looking okay. There's no obvious silly things coming up here. And it's not working. Okay, am I passing it properly over? I don't know. Am I passing it properly over? Oh, wait a minute. Output. Ah, that was my fault. There you go. That's a proper close. Output. Yeah, that's good. Error list. Nothing. Nothing. Great. Helpful. I'm calculating it. Am I calculating it? Yeah, I put it into window initialization, didn't I? Set perspective with height. Set perspective gets called with width height, with the width and the height of the current values, which is correct, because we're calling it in there and it becomes width. Yeah, that's correct. So it comes in at the correct values, gets called, is the correct values. In the header file, we can access it. And perspective, make sure I have used the correct variables. And perspective equals whatever the perspective is. I can't see it. I can't see an error. By the time we've got there, the initialization has already happened. Let's see if Calc Model Matrix is working. Let's go back 10 meters, for instance. So perspective is working to a point. It's not doing our division. It's not doing the aspect ratio. Why is GLM not doing aspect ratios when it's supposed to? That's what our square looks like 10 meters away. I mean, I can. update the calculation, can't I? So I could actually do it like I could do a terrain calculation each time, you see. That's interesting, I just had a thought. Because I haven't done the other half to this yet, have I? I've only done the front half to get it working. Right, okay. Where's my coffee? This is where programming is hard to explain. I know it's working, and I think it is working as intended. I'm just wondering if it's got a reversal system on it. I mean, really, it's hard to tell. The only place I can play with this is in here, really. So, what is a 9 to 5? It's 9 divided by 5, width over height. Okay. If I put in aspect ratio here, equals, let's do it wrong to start off with. Static, and it's going to be cast, isn't it? Cast. And then we just put the calculation in. I'm going to do it the wrong way round. Actually, I can just put height over. So I know it's wrong. Because that's not how I would do it. And I call this aspect. So I know there's something weird going on here. That enables me now to play with it. Quite happily. So aspect ratio. What happens if I run that? Okay. Are we happy? Are we not happy? There we go. We don't get what we're after. As soon as we change that to a width over height, it should be 1.33, I'm sure. We get that. Let me just try an aspect ratio of 1.33. Oh. Stupid me. Forgot me F. As I do. I thought so. There's something weird going on here. Aspect ratio equals 1. How can it equal 1? Width is 900, height is 500, aspect ratio equals 1. Oh no. Oh no, don't tell me I've done that a silly mistake. With the brackets. Please don't tell me. I made it calculate it wrongly. There you go. I made it calculate it wrongly. That's the answer. My apologies. Big apologies. I did a bad equation. I've used my static cast wrongly. Static cast can only cast one variable at a time, not two. So the answer is static cast float width over height. So I can now cut that out and change it for that. Yeah, bring back that bit, please. There we go. Only one of these needs to be a float for the result to end up a float. It's a little trick with C++. If an integer on either side is used, I could put the static cast on the height or the width. Doesn't matter which, but I can only put it on one of them. But if an integer and a float are mixed into the same equation, the answer will always come out as a float due to the floating accuracy that you may be wishing to get. It's a standard procedure within C++ to do that. And I completely messed it up, as you can see. Sorry. So yeah, the program's right. Oh, gosh. How did I do that one? Can you see the difference? Right, let's put it back to where it should be without me messing about now. So let's bring it back to the front 1 meter away. And as you're now going to see, it's no longer a rectangle. We have a square. Look at the up-down stretch though. And this is what I was saying about the field of view. I want to mess about now with the field of view to get that square more square. To me, that looks bigger going downwards than it does across now. It looks as though we shrunk too much left to right and up. Up and down hasn't shrunk enough. So it seems to have applied the left and right, but not the top and bottom. So let's have a look at our field of view. I knew that was going to happen, field of view thingy, so don't worry. That bit I'm used to. It's a bit that I have a little bit of a problem with. Change it to 133. Let's put it back to 100. And check it again, see if it goes worse. It's 1 radian, that, not 1 degree. But it'll affect our up-down stretch. I'm hoping. Yeah, as you can see, 1 is way out. Or is it? Interesting. I know that radians can work slightly differently with this equation, and especially the field of view, depending on what you set it to. Some people just set it to 65 degrees and leave it there. But another 1.45 is getting there. Will that squash it up enough into a box? That is a square now. Am I happy that that's a square? Funnily enough, yes, I am. I think it's worked. I'm happy. It's worked. We have perspective. What don't we have? A camera. Also, what don't we have? Yeah, things in the right place. Here's the problem that we next face. Sorry, I forgot to point it out. What's going on? That has to remain a square, and look, I can even wipe it out. You know, it's just not going right, is it? Alright, and this presents us with a big difficulty, because we're not in control of that. And that is the biggest point of this, is that, yikes, we are not in control of anything that the operating system does. So we are going to have to create an operating system interface. Yeah. Let's create an operating system interface. We can do that within the initialization, can't we? Yeah, we can. Let's have a look at our initialization here. So in display, initialize. As you can see, I've been filling these in as I've been going, so this is now standard. Game, that's not going to survive like that. I'm not filling it in. I don't want that to survive. I don't want that to survive. I am not going to fill the rest of that in either. So that might not survive as is. You can tell when I've got things that are not going to probably survive, I stop doing the notes instantly. So, back here at the window. We initialize, we enable, we clear color. We set our perspectives, and we do that here. That's where we set our perspectives. So anything that we want to do about callbacks or operating system taking over really has to come around where we're doing our GLFW. Oh God, no. Do context. I'm not happy with set perspective being there. I know it's in the correct place, but really we can still get return false. So no, I'm taking it out of there. Cut. And I'll put it after the last possible one of these. There's no point in calculating it if we haven't got there. That's return true, that's return false. That's the last return false. Okay. So popping you in there. So that's our perspective done. Now what we're looking to do is set up GLFW. I'm going to set it up to do callbacks. So after we've got the context and all the rest of that, once we've calculated our perspective, we can set up our callbacks here. Yeah, I'll just do that. Operating system. I should only do 4 or 5 of those. I shouldn't do a massive lot there. It's not meant to be. There we go. Because there's going to be a few of these. The one that we want is the bits that deal with the windows. Now, GLFW gives us, as a user or programmer, a pointer that we can use for this. So it's actually intentionally been done, which is why I like GLFW. It'll give us direct access to the operating system, and it's how GLFW actually expects us to do it, which is even nicer, because direct access means speed of response. And that is very important, especially when you're dealing with 3D. You don't want your operating system messing about with your rendering system. So you want to keep them separate. So what I've got is in the window 3D, we're going to set it all up here because that's where we're using GLFW. We don't use it anywhere else. And we're setting that up here. Everywhere else we've been using OpenGL, which is actually glue. Is the OpenGL function. So it's glue that we've been using for the GL. So just an interesting, differential between what you may think and what we're actually doing. So GLFW, do you have a set window? What will it be? It'll be user, won't it? Yes, it is user pointer. That's the one. All this will need is, oh gosh, brief sets the user pointer at the specified window. This function sets the user-defined pointer at the specified window. The current value is retained until the window is destroyed. The initial value is null. The window whose pointer to set pointer to the new value. Possible errors include not initialized. No, we've dealt with that. Thread safety. This function may be called from any thread. No, I'm going to get around that later. Because we are going to have multiple threads. Synchronized. Ref window user pointer. Yep, ref glf window get window user pointer, which we will need. Okay, that looks quite simple and straightforward to me. All we're going to do is put in our window. Isn't that just this? No, it won't be, will it? What we called our window? M window. Comma. And now it needs a void star pointer, and that we can just say, well, it's this. It wants a void star pointer to M window. Well, if I type in this and then put an arrow, as you can see, it's got clear screen, initialize window. This is your window. It's a pointer to everything that we've got in window. So we can just use the command or control word. C++ control specific word is this. And that's a command. That's a C++ command that creates an automatic pointer to whatever object you are in. And we are in... we're in whatever that is there. Game display, and then whatever our Dubra is in, our class. So, yeah. Sorry. Where is it again? So it's in our class, which is this. That is the this value. Okay. So that's what we're inside that class. So that's nice and easy. That now gives us a pointer. For now, I'm just interested in window size. So resizing of a window with a mouse pointer. So using that pointer, I want to set up a callback. Now, when you set up a callback, you have to declare it within your main functionality of the program. And because this initialize has to be correct and has to not return false, and at this point means we have a window and everything's hunky-dory and is working, that I can now say, let's set up a window size callback. So resizing of the windows. GLFW should have something for us here. GLFW. Will it have a set window? How's about size? Oh yeah, we've got a callback. Yep, size callback. Let's try that one. This needs the window, which is mwindow, is it? I think so. Yeah. m_window is a... okay. I don't know if it is or not. Is that a dot? No. Good. Right, okay. So that'll work. Hello. And then we'll need win size function. So a CB function. Okay. Okay, we'll need a window function. What should we call it? How about window resize? C. Does say C, doesn't it? C-based function. Yeah, C-based function. Okay. So I can have that. That doesn't exist. Okay, that's going to cause us a problem. We need to make that exist. How can we make that exist? Let's have a look at the header file and see what we can do there. Muppet, hello, love. What are you up to? Are you come to say to Daddy that you want food? Well, tough. I'm programming. I'm actually enjoying this part. We're doing the window. Finally getting to do this. And I do find it difficult, actually. Especially when we get to callbacks. I'm never quite sure how I want to do them. Interesting. How are we going to set this? We can just leave it out there, can we? Muppet, don't sit on the keyboards, please. Oh God, Muppet sitting on my keyboard. Get out, get out. Come on, move, 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 move. Come on, move. Move, come on, move. Oh, there you go. You are a bit clumsy at times. He's a bit clumsy, especially when he sits on the keyboard. He just make a mess. Here we go. How can I do it on this side? Window resize. Where the heck can I put this? At the top, maybe? Well, if I declare it up at the top, yeah, okay. That should get rid of these lines here. So that's a start. So under display, here we go. Right, this one I do mean to be a big one, so halfway across, I'll put callbacks. Quite a lot of lines, please, like that. Okay, that's our callbacks area. Notice that it's not, it's just in display, namespace display. It's not anywhere else. I could put it with these defines, I suppose. That's why I was looking at the header file. Should I put it with the defines? No, we'll have it here. We'll have it at the top of the CPP file, because I think I'll probably expect it more there. Void, and it's window underscore resize. Open brackets. Okay, G L F W window. Star window, yeah. What else will we need? Oh yeah, the width and height. Int width, comma, int height, because those are in pixels. H-I-G-H-D. Okay, we can do that. Lovely. What this now is, callbacks. I'm just going to prop in bracket declarations. Yeah, I'm going to put my declarations here. Now, your callbacks aren't part of your class. Okay? They're not actually part of the class. So all I'm doing is making a note that I've made a declaration here for window resize. As you can see, it's already coming up with this little doobie thingy. Create definition of window resize in here. Well, I'm going to do it myself, so no. What I'm going to do is I'm going to take that line, copy it, and I think to keep it all clean, I'm going to do my callbacks at the bottom. So as long as we declared it, we can use it. So where we used it, set perspective, there you go. Window resize, we now have it. There you go, it's GLF window star. Yeah, it's all there, we can now use it. Which means we can now put callbacks in here. So it's one, that'll do. Callbacks, open, and this is definitions. Okay. So this is where I can now define them. So it's like having a header file and a CPP file. I'm splitting them up again. You don't have to. You could put it all at the top if you wanted to. But it will, as we do more callbacks, you'll see that it gets in the way of the window 3D stuff if you start doing it all up there. So it's just, I know where to find stuff if I keep doing it this way. Does that make sense? Yeah, of course it does. Just gets it out of the way, as far as I'm concerned. So it gets the definition out of the way, but it does it in such a way that I can use it. That's the best way of putting it. So the definition for this, what we're going to do really is use an OpenGL viewport thingy, aren't we? So does it? We have it, don't we? Yeah, viewport. There we go. I've got a hair on the top. There we go. So we're going to use the viewport, and the viewport takes x 0, comma y 0. Suppose we'll start at top left. Or is it bottom left? Bottom left. Or center. Who cares? Who cares? Width height. Work that out in a minute. I'm actually interested to know that one. And that's all it needs. So what that does is it changes the size of the OpenGL viewport. So before, what was happening when I was dragging it around the screen is it still only had that little diddy viewport, but I was dragging the window out, but the viewport was still only that little diddy bit at the top. You couldn't see it properly because of the background colour being coloured in. God knows why. Shouldn't have been. What are we going to do with this? We need a window 3D pointer. So we can do that, can't we? Yeah, we can. The window 3Ds here. It's available to us. We'll have a pointer for Windows. That equals a static cast. God, this is awkward. Static cast. You've met that before now. You know what that means, but we want it to window 3D. So we now want to cast the GLFW pointer into the type of window 3D star. Sorry, missed it. And that open bracket, and it's GLFW. Now it's that get window pointer, isn't it? There it is. Get your window user pointer. There it is. And that takes window. Whatever we passed in there. GLFW window, star window. There we go. That's that. Don't know how to split that down, really. Should do. Like that. That's the true meaning of that. All we're doing is we are taking the passed in window value and converting it to the type that we want, which is window 3D. Because we only deal with window 3D, you see, for setting perspective and stuff. So we want to take whatever the operating system gives us and make sure it's a window 3D. Good stuff. Okay, so we've done that. All we need to do now is tell our window to set the perspective, because we've just made that. This joins on to that bit there, which will then change M perspective. M perspective is automatically picked up by our renderer, or gets automatically supplied to our renderer. So the perspective then is given to us by the operating system, picked up by M perspective, and then picked up by our renderer, and we use the correct perspective for the window. Does that sound good? So win, we just converted it over into a star. So and we can't set perspective because it's private. Sorry. My bad. Goes in there. And that puts that there. I wanted it all to fit together, but it's not going to. Sorry, I was trying to get it all to fit together so you could see it all at once. But it now has to be cut and put above this, unfortunately. Shame. There you go, it goes there. So update, set perspective. That's a damn shame, because that initialize is pretty big. So it's window. We'll try that again, shall we? Ah, set perspective. What does that want then? Shift, open, ding. And it wants width, comma, height. And that's it. That's all it wants. There we go. That's it. And that will do it for us. So this is a callback. It will come through from the operating system. And that means that we have to initiate it. We have to initiate all callbacks. It's not like interrupts in the old days with C. C++, we gain control. So every time in game that we go through this loop, this while loop, we want to be asking the operating system, hey, got any updates for us? You know, update window 3D should be a good place to put it, I think. So, yeah, have we already put it in? Don't know, actually. Did you have the forward thinking at that stage, and did I mistakenly put it in? Yes, we have. Check with operating system for any events. There you go, GLFW poll events. You can read it yourselves. And that all then matches up, and that means callback. Okay. How can we put this? Function given by GLFW for to set a pointer that the operating system can use, or can be used on the operating system. Yeah, done it again. Can be used on the operating system. Yeah, okay. Get rid of that bit. Doesn't really matter. Function, okay. Yep, that's okay. This part is the window. Sorry. This. Yeah, this is the window that the pointer will refer to. And this is, no, this is the object it belongs to. The object, the point. I'm trying to make this into English. That pointer belongs to. That is sort of my idea of how it looks. The window whose pointer to set. Okay. User-defined pointer of specified window. That's probably better than my explanation. User-defined. Pointer for the specified window. User-defined pointer specified window. Yeah, okay, I'm going to leave it as that now. That's okay. System callback. to... It's just a system callback, isn't it? Doesn't matter what name it gives it, it's still just a system callback. Is it just referring to, or... That's the specified window. The specified window. And that's the function to be called. Callback to resize a window. There we go. Specified window, function to be called. Excellent. That makes sense now. That makes perfect sense. That's better. What I want to do after that? No, not that line. That line there. Let's just put one of these in. Just a small one. So I can break that off there. Okay. Right, I'm happy. I'm happy that that's going to work alright. There's a real way to find out, isn't there? If I've set it up right, then it works automatically. If I haven't, it'll just go error, crash. Dun, 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 dun. I need a drum roll. Where do I get a drum roll from? Somebody tell me. Drum roll. Okay, stretch it over that way. It's not doing it in real time, but it's working. You can see it's moving and it's always trying to make a square. Why isn't it doing it in real time and updating in real time? See how it's now getting larger? You can now resize it to massive. Wow, that works brilliantly. I'm actually impressed. I don't like this. That might be a Windows setting. Animate Windows. I might have a setting missing off my Windows system because I've never set it up. I just took it as it was when it came through the door and just use it. But that's working. You test that yourselves. If you have got yours animated and it's working nicely, then well done. Yeah, the poll request should not be hesitating. Let me just check. Poll requests. Here we go. Thread safety. This function must only be called from the main thread. Well, yeah, done that. But is it blocking or is it thread blocking? Event queue, and then returns immediately. Processing events will cause the window and input callback associated with those events to be called. Yeah, well, that's what we set up. To block. Ah, right. Yeah, so it could. This is due to how event processing is designed on those platforms. You can use the window refresh callback to redraw the contents of your window when necessary during such operations. So there is a way around it as well. That's good news. Okay. Wow. 2.5 hours. We have our window sorted fully. We have a 3D object sorted fully. Hold on a minute. We got a 3D object. Let's give me an idea. No, don't do it. Yeah, no, don't do it. No, I want to get the 3D object, as a proper terrain object now. We've got the object. That's fine. All I'm going to do now in render CPP is just do something silly to make sure it's moving okay. I want to see what it looks like. No, we can close all this. Right, okay. That's worked out brilliantly in my book. So now I've got the window update. No, I'm not doing any more to it, because this is all going to alter. And the more I mess about now, the more I'm going to have to alter. Alright. Next, we need to sort out our entity. Because, well, this is rubbish. So I need to sit down now and work out our entity. What we're going to do with it. So what can we do with it? What kind of structure can we have? Yeah. Let's have a look, shall we? I don't know if I have to plug this in or not, do I? Alright, there we go. Okay, switched on. So yeah, we've got stuff here. What a ballpoint pen, please. Thank you. So what we now have is probably something like we're going to need a model. So we'll put this over here. And we are going to need some kind of entity, obviously. But what's the difference between a model and an entity? That's the question. A lot. A model should include the OpenGL stuff. So anything OpenGL goes in your model. Alright? An entity doesn't. A model should have any calculations required. So any calculations should be in the model. No, sorry, bad. Scrub that out for a minute. Can I scrub that out properly? I don't know. Oops. Oh, yes, I can. Right, okay. So here under entity, we're going to do our matrix. If I can get this to work again now. Oh, it's gone off that, has it? I have to put it back on. A colour, okay. So, matrix. No, I'm not getting anything. Help, help. Oh, right, okay. Reset. I think I need to plug it in. So on the right hand side, I'll put that down a second. Haven't got the hang of that yet. Can I have my mouse back now? So on the right hand side here, we're going to have our matrix or mat 4s. And that will by itself declare that we need position, rotation and scale. Is there anything else we need to know about the entity? At this stage, no. So what we're going to do is we're going to split it off into two things. We're going to transfer our OpenGL to a model so that we have a model separated here from the entity. So that's just going to be a mat4 and a model. really is all we're putting in here. So that's those two. Can't really think of anything else that's going to go in that. So yeah, that's what we're going to be doing next. And I think that should work. So that will disappear. Lovely. Let's make that disappear. So, entity. No, I should leave it so it can run, shouldn't I? Yeah, I'll leave it as a runnable, compilable and runnable. So you can see that we've now gone from an oblong to a square. And now we can resize and it stays square. Clever. So we've added perspective, and I'm hoping that we have added translation, rotation and scaling. Not really tested that. Up is the Y direction, isn't it? X-axis goes across, up is the Y direction. So we'll try rotating 45 degrees around the Y-axis. Actually, no, we'll go 40 degrees. Position, rotation. Okay, we'll just do 40 degrees around the Y-axis and see what happens. Just to see what kind of shape it does. Better stop the program first. Whoops. There we go. And that's the angle it comes up with. Which is interesting. I wasn't expecting that. Help. I can't explain that. But that's right, I suppose. Pardon? Can I put it back to 0? Am I seeing that right? Yeah, I am. God damn. That was interesting. Right, I'm going to go and do some playing around with this. So I will catch you in the next episode. In the meantime, I'd like you to all play around with this code. It's correct up to a point, I think. I'm going to go and play with rotations and find out exactly what the heck's going on with this rotational stuff. And once I'm happy with that, we'll carry on tomorrow to do the models and the entities. So, in the meantime, all I can really say is take care, and above all, have fun.